Lesson 25, Comparison Test. You can also determine convergence or divergence of an infinite series by comparison test. And there are two comparison tests you can use. One is called a direct comparison test, and then the second one is called a limit comparison test. Now let me show you how the direct comparison test actually works. Let sum of A sub n and sum of B sub n be two series in which A sub n is actually less than B sub n. Then if B converges, then A also converges. And if A diverges, then B also diverges. So in other words, if one is convergent or divergent, then usually the other series follows suit. Let's look at an example where we are using the direct comparison test to determine convergence or divergence. For this given series, use just the regular comparison test to determine if the following series converges or diverges. Well, from this series, we can make our own series to compare. to compare. So we can just say 1 over n to the 13 over 2 power is our series. And the given series is less than our series. If you plugged in a few numbers for n, that would confirm that. Now, 1 over n to the 13 over 2 power is a p series. And if p is greater than 1, then our series converges. That is the case here. P is the exponent 13 over 2, and 13 over 2 is greater than 1. So because our series converges, then the given series also converges by the comparison test. Let's look at the other comparison test. This one is called the limit comparison test. And you're given two series, one that's given, the original problem, and then the other one is our made-up series. Number one, if you take the limit as n approaches infinity of a sub n over b sub n, and you get an actual constant, positive constant, and we have that constant is greater than 0 or positive, then the two series either both converge or both diverge. Second possible answer is when you take the limit and you get 0 and B converges, then A also converges. And the last possible answer is you get infinity. If you get infinity and B diverges, then the other series also diverges. So that's the three possible answers for the limit comparison test. Question 2. Use the limit comparison test to determine if the following series converges or diverges. Now, you're not always going to be given a hint as to what your series, your made-up series should be. Let me show you how my math lab got 1 over n squared. They just took the first term and divided it by the first term in the original series, and that's how they got our made-up series 1 over n squared. So a sub n is the original series, and b sub n is our series 1 over n squared. And let's divide the two series, a sub n over b sub n. Now right here, when you divide by 1 over n squared, that of course flips and turns into n squared up top. And you multiply n squared times n minus 7, and that gives us n cubed minus 7n squared up at the top. Now you can take the limit as n approaches positive infinity of a sub n over b sub n. Now you don't have to do anything extra, you don't have to divide or anything of that sort. Remember, if you're taking the limit as n approaches infinity and your numerator and your denominator's exponents are the same, then just take the ratio of the two terms in front of the coefficients, and that's an easy way to get your the value of your limit. So our limit is equal to 1. So that means because we got a positive limit, then either both series converge or both series diverge. Well, our given series, 1 over n squared, is a p series with p the exponent equal to 2. And because our exponent is greater than 1, that means our made-up series converges. Now, because our made-up series converges, then that means the given series also converges by the limit comparison test. Let's look at this example. Find out whether the series given below converges or diverges. And we can use the limit comparison test. Just as a reminder, here are all the possible answers and situations. Now we have to come up with our own made-up series. So let's to start off, b sub n equal to 1 over 4 times square root of n. Or we can actually simplify that a little bit further and just use 1 over square root of n. Now keep in mind, 1 over square root of n is the same thing as 1 over n to the 1/2 power. And this is a p series. Now because p is 1/2, and that is less than 1, then that means our made-up series is divergent. So keep that in mind as we find the ratio of a over b. So we do a sub n over b sub n. And right here, the 1 over square root of n, it flips. And the square root of n goes on top at the numerator. Now you don't have to follow what my math lab does here next. I think my math lab divided everything by square root of n or something like that. Whenever you take the limit as n approaches positive infinity, and we have a sub n over b sub n, well, Square root of n is the same thing as n to the 1/2 power, and that's the case for both the numerator and denominator. They're the same highest exponent, so the easy way to find the limit is take the ratio of the two coefficients in front of our variables. So that right here is 1/4. Now, 1/4 is positive, and because our given series diverged, then the original series a sub n also has to follow suit. So by the limit comparison test, the original series a sub n also diverges.